So good afternoon, my dear colleagues. Let me introduce myself. My name is Rita Kuznetsova, and I'm a head of research department of Antiplagiat joint stock company. And for today, me and my dearest colleagues prepared this presentation. So I'm going to tell you about our main tasks and how we detect some non-trivial cases of plagiarism. And the main purpose of my presentation is to tell you about our approaches and some difficult cases. So I've divided my presentation into these parts that correspond to our main topic. And some facts about anti-plagiat system. Maybe some of you have heard about this, and maybe some of you use it for checking your work for the percent of plagiarism. So some facts that anti-plagiat system detects text reuse in any language and for any popular file type. And also this system discovers cheating. And a few numbers. So we help our 500 university to check their works for plagiarism. We have about 140 million sources in our search databases, and every year we checked about 25 million texts. So while the company of Antiplagiat successfully deals with cheating discovery in the production scale, so the main goal of the research department is experiments in the state-of-the-art techniques and in the area of the natural language processing and plagiarism detection. So on his slide, you can see some beautiful statements about us and some beautiful words, but it's just words. And on the next slide, you can see the proof of their words. So our success story started at October 14 with our first projects for Antiplagiat company. And this project was so successful. So in August last year, we took part in our first conference, FRUCT. Then in November last year, we had a comprehensive study on machine-generated text detection in real-world big data. I will tell you later what it means. So in April this year, we took part in a PAN competition. PAN competition is the largest competition in the world, provides the detection plagiarism task. So we took part in a track named authorization, and we won this track. And at this year, we ended the development of cross-language plagiarism detection tool powered by state-of-art techniques. So, and now we can use these results for detecting some non-trivial cases such as paraphrasing. So here you can see the main areas of our interest. For some of them, for example, cross-language plagiarism or authorization, we are working for a long time. And for example, for paraphrase detection, we started to work recent. So let's look our problems in focus. And firstly, let's define in this presentation what is the type of text reuse. So in this presentation, we define the text reuse. So we can classify this reuse for several categories. So here we are. The first category is copying text as this, so copy-paste. It's the second, we can paraphrase our text, and the third, I think it's the most difficult case. We can translate text from another language. So let's see the third case in more details. This problem is not new and has ancient origins. So on these two slides, you can see the most famous cases, and I couldn't see, so that is plagiarism. But the idea is basically borrowed up the names of main heroes and plot of these books. So now you understand why it's so serious. And the problem is that a large amounts of text of students' work, large amounts of data from a web contain reused fragments from another language. It's a very difficult task. To detect plagiarism in case of pair English-Russian, because these two languages aren't close to each other. And the methods that uses machine translation generates text too much differ from the source. So our goal is to develop a tool for cross-lingual plagiarism detection in a case of languages Russian and English, based on a monolingual approach. What does it mean? A monolingual approach means that our suspicious documents in Russian, firstly, we translate these documents into English. So, on this slide, you can see the overall scheme of our algorithm's work. There are two main stages. The stage of candidate retrieval and the stage of detailed analysis. Given suspicious Russian document and English document collection. At the first stage, the task is to find a candidate which possibly contains reused text from the suspicious documents into collection, and then rank it according to their relevance value. So the suspicious Russian document was translated using statistical machine translation system. For this purpose, we used pre-trained models. Maybe you know what is it. And in the stage a detailed analysis, when we have a suspicious document and a candidate, then we split our documents according to some segmentation, some blocks, n-grams, sentence, etc. We map our sentences into a multidimensional feature space based on deep learning techniques, and to compare segments with each other. The segments with the highest score are marked as plagiarized. So it's a whole idea. We presented this approach, and on the slide you can see the 3-hour papers, and if you're interested in details, you can see these papers. So, the next main topic of my presentation is the machine-generated text detection problem. So this problem is not new, because tools for paper generation have been available for 10 years already. So, and our goal is to determine is a text or text fragment is machine detected or not. We always include in this definition of machine-generated text, machine-translated text. So, here you can see the example. Today we can write a paper with one click. So this is a famous tool named SciGen. Its tool generates paper on a computer science topic, and maybe it uses in his work the context-free grammar. So, and maybe you have heard the little bit scandalous situation when the paper was generated by this tool, and then this paper was accepted in journal, in review, despite that fact that the content of this paper was totally meaningless. But this is not the end of the story, because a few years later, this paper, named Rita, was translated into Russian, and after a minimal correctness mistake for machine translation, this paper was accepted in journal, in review. The name of this paper is Корчеватель, and maybe you have heard about this. So, and you can see here one more example. This tool named MathGAN, it randomly generates math papers, including some theorems, definitions, mathematical proposals, etc. So now you can see that's a very serious problem, because also automatic detection of such papers should deal with big data, because past research in this field detected hundreds of papers in such journals like Elsevier, Springer, etc. So this detection should be applicable for the Russian language, and also detects machine translation text, because in some cases machine translated text contains some machine translated errors. So, and here, as I said earlier, in November last year, we had big research. We tried to find their paper like Rita and Корчеватель in collection of our partner, eLibrary. So eLibrary is the largest digital library of scientific papers. So we need to solve two classification tests. First, we need to solve classification task, is text machine generated or not, and the second task is to determine is the content of paper scientific or not. We could say if paper scientific or not only after the expert opinion or expert conclusion. But the main goal of this classification was to form a scope of papers that content may be unscientific. So, the results. We didn't find any machine-generated text in the collection of eLibrary. It's a very good result. So, what we found? We found congratulations, business news, interviews, memorials, patents, so on. So, in fact, we did the whole analysis of eLibrary collection and automatically categorized the paper of eLibrary in a more intellectual way, I think. So, and on this slide, you can see the example of a paper which marked our classifier as non-scientific. So you can see it's fly pie to the oven and in a scientific journal on baking bread. So I think it's a very funny example. And classifier thought this paper non-scientific. Maybe it's true. So on the other side, we try to detect the machine translated, because especially after recent advantages in the field of statistical machine translation, it's very easy to find the relevance information in the web, translate it automatically, and to use it in your work. So our research focuses on the phrase salad phenomenon. What is it? What does it mean? So after translation, the result of translation may consist as subphrases, and each subphrase is grammatically correct. But together, they are combined in an improper way. So you can see here the first sentence is the original sentence. The second sentence is the result of translation. And we can see that the first half of a sentence is grammatically correct. The second half of a sentence is grammatically correct. But together, they're combined in an improper way. So our solution design is quite simple. We try to estimate the likelihood that a sentence is machine translated according to several language models. So you can see the full list of these language models. So, and then we used these estimations as features for classification task. We presented this approach at this year at Dialogue Conference, the largest conference in computer linguistic fields. And if you're interested in details about how algorithms work, you're welcome to look our paper. So, the last, our main topic of research is intrinsic plagiarism detection task. What does it mean? Maybe you know that there are two main approaches for plagiarism detection: external plagiarism detection task and intrinsic plagiarism detection task. External is when we try to detect the plagiarized segments, and we based on a reference corpus. Intrinsic, it's when we try to detect the plagiarized parts in a text by analyzing only the writing style of this text, only the writing style, and no external collection. This means even if suspicious text parts are found, there is no still guarantee that they are truly plagiarized, because we have only one text and we haven't got any collection. On the other side, no further possibilities to uncover plagiarism, or beside detecting suspicious text parts which strongly differ from the rest of our text. So that's why this problem is so hard. And as I said earlier, me and my dearest colleagues from Moscow Institute of Physics and Technology and from Computer Center of Russian Academy of Science took part in a PAN competition. PAN is, as I said earlier, the largest competition for plagiarism detection. And we took part in intrinsic plagiarism detection task and won it. So here you can see their tasks. At this year, PAN organizers provide more general settings for intrinsic plagiarism detection named authorization. So the first subtask is quite simple. It's classical intrinsic plagiarism detection formulation. There is a text, and there is one main author who writes this text, at least 70%. And other 30% are maybe written by the others. But in authorization, there are n of authors, and no main author is given. In this task, each author may contribute an arbitrary extent, and so the number of n may be known or unknown. So our win solution design, it's quite simple, because the most algorithms work in this field are based on a following scheme. On the first stage, we split our text according to some segmentation. It's maybe sentence, n-grams, overlapping blocks, as you wish. On the second stage, we map each segment to the feature space. After that, we combine these features to an author style function. And then, in case of intrinsic plagiarism detection, we detect the outliers in statistics. So on this page on left, you can see the blue line is a text statistics, so-called author style function. The red vertical lines is the plagiarized segments. So in our case, it's outliers. And the red horizontal line is a threshold value. And for authorization task, we use the clustering approach. So, and in the picture on the right side, you can see also style function and segments with different colors, which corresponds to different authors. We presented this approach at PANCLEF conference at September this year. So, and for details, you can welcome to see our paper. In conclusion to this section, I want to say that intrinsic plagiarism detection task is very hard because the maximum of measure in this task is about 40%. 40% since, I think, 2009 year. So, and I can say that nowadays this task is unsolved, and maybe you can try to solve it. So, and in the end of my presentation, I will tell you about some of our collaboration opportunities. So, on this slide, you can see some way to cooperate with us. So, some research studies, for example, for intrinsic plagiarism detection, we cooperated with Dr. Vadim Strizhov. Maybe you heard this today. And for example, for some project, we collaborate with Dr. Alexandrov, you can see. And I think we have great internship opportunities because this year we had Georgia's internship, and also we lead some thesis research. And nowadays, for this moment, we have 4 students from Moscow Institute of Physics and Technology, from the Higher School of Economics, and from Moscow State University. And we do some mentorship on it. And to conclude my presentation, I'm pleased to introduce you the new competition, plagiarism detection, that will hold a dialogue conference, so at the next of year, with support of PAN, and Cyberlenica. And on this web link, you can see the details, the rules of this competition, the training data, and so on. So you're welcome to participate. Thank you very much for your attention.
I think we have something about 15 minutes. Any questions?
Thank you very much. It was quite interesting. I'd like to ask you about the task of classifying papers to significant not. In fact, it's just 2 questions closely related. What was your training data set, and how do you evaluate if a paper is significant?
So our training set consists some thesis, some scientific papers from Sabelenica, and this scientific was proved by experts. Our AINL scientific training set consists of some books, non-scientific, some fiction books, I think, and yes, that's all on. And about evaluation and
yeah, so in fact you just answered all the question. So you didn't treat this as anomaly detection, but you treat it as a just classification.
so in intrinsic or in a
No, in
yes, it's classification task because we solved the binary classification task. So is text scientific or not?
Okay, have you
Based
tried,
on a retrained model.
Have you tried Kirchhoff for your
Yes.
model? And the conclusion was?
Depends by threshold.
Yeah.
What machine translation system do you use
What translation system and what task?
in the task of cross-language plagiarism detection? You said that you
Yes,
translate text
we
first
use
and
the open source statistical machine translation system named Moses,
then- okay.
and we trained Moses on a parallel corpora. So
Yes, okay.
My question is, you have two class classifications, scientific and not scientific papers, yes? But how can you evaluate the papers in Wikipedia related to sciences? It's a popular science, so how do you evaluate this type of papers?
how our
Popular
popular
scientific
science.
papers. And manuals for students.
I think it's scientific. Our algorithm thinks it's scientific.
Yes.
And what approach is more popular, the most successful in your research? For example, stylometrics, you understand, a structure, a method based on structure, on the sentences, or pure lexical?
In
Wow.
this approach, we combined features. So the algorithms work based on a group of stylometrical features, and there are always lexical features. And we try to determine the structure of a paper. So there's a whole combination of features, yes.
Thank you for the great talk. Well, I know almost nothing about intrinsic plagiarism detection, and I remember there was a reference, but still, could you say just a few words about what kind of style function you use, and what kind of evaluation metric is used on segmentation in intrinsic plagiarism detection?
So style function is statistics. In our work, we use the long and the short mean, the difference between the long and the short mean. Long and short mean.
Mean of what?
Mean, it's a среднее.
I know it's srednje, but what's srednje what?
So after we construct, after we map each our segments into a feature space, we trained a classifier using the true labels of the sentences. Is sentences is suspicious or not? And when we train a classifier, we use information about two sentences behind and two sentences in the next. So we use this information, train the classifier, and then we used the output of this classifier, and formed two statistics. Long mean is we use the output of classifier and some weight, some pre-trained weight. And for the short mean, it's also some weight some another weight, pre-trained and output of classifier. The difference between these two statistics, that's our, and if and we compare this difference by threshold. So this is also style function, and maybe your second question is evaluation metrics in this task. It's a standard evaluation metrics, precision, recall, end of measure.
So it was the plagiarized parts are like 1 plus,
Yes.
Okay. And well, actually, my first question was about the features you used.
Features. Okay. It's frequency of n-grams, frequency of words, number of punctuations, set of unique symbols, some standard features, I think.
Anything?
Any more questions? Yep.
There is a very horrible example of plagiarism when author paper, for example, is translated from one language to another. Do you think that intrinsic evaluation can help or
In this task,
yes?
in translation, so it's, I think now it's not, because the quality of intrinsic plagiarism algorithms is very low. But maybe if this approach grows, yes, maybe yes. Because the parts of the text which we translated significantly stronger from the other parts. Maybe it helps.
But if you compare one sentence
To another sentence of this text. So.
So if it all will be translated, it will not help, right?
Yes, it will help. If we translated all the text, it will help. No.
Any more questions?